Hello, welcome to this webinar. This webinar is a deep dive on Amazon S3 security and management. My name is PD Datta. I'm a senior product manager in Amazon S3. Since this is a deep dive, I expect that you know or have heard about AWS and Amazon S3, although I will be giving some context as and when I browse through my slides. So let's begin. So this is what you should expect from this webinar. We're going to first start off by talking about the different access control mechanisms that you have in Amazon S3 to secure and protect your data. We're going to switch gears and talk about a new feature that we launched a few days ago. It's called Amazon S3 Block Public Access. Then we're going to move to how Amazon S3 authorizes a request. We're going to switch gears and talk about S3 encryption. And then finally, we're going to close with how you monitor security in Amazon S3. So say you've created a new account and you go to the S3 console and you're wondering to create an S3 bucket. You probably would be thinking, how can I help ensure the files in my Amazon S3 bucket are secure? So when using AWS, it's best practice to restrict your access to your resources to only the people that absolutely need it. That's the principle of least privilege. Now by default, newly created S3 resources are private, and the access is restricted only to the resource owner. The resource owner can then explicitly grant access to other users. So pro tip 1, it's best practice never to open access to the public. Most of your use cases won't require a broad-ranging anonymous or public access to read files from your S3 buckets, unless of course you're using S3 to host public assets such as hosting images in a public website. If you do so, it is easier and safer to relax permissions over time than to tighten it up after the fact. Also, it enables more granular control than overly permissive policies. Now, defining the right set of permissions requires some research. You probably would like to learn how can you manage control, what type of access control mechanisms a service supports, what permissions are required to perform those actions. And we're going to look into those in the next few slides. When you're thinking of managing access control to buckets and objects in S3, these are the different control mechanisms when it comes to securing your data. Now you could use all of them or just stick to the first two to manage access to your data. Now in the following slides, we're going to go a little deeper on what each of these can do. Now remember, there are two jobs or two parts to securing your data in AWS. The first is specification. This is your or the customer's job. This is where you define the access policy with the permissions that you want, and then you attach it to the users or the resources in AWS. Second comes enforcement. This is our job. This is where we evaluate the different policies, we authenticate requests, and we authorize it. So let's start with IAM. AWS Identity and Access Management is a free authentication and authorization service for AWS. So in other words, you can use IAM to control who can access your AWS resources and how they can use them. So when thinking of IAM, the first thing that comes to mind is a principal. A principal is an entity that can make a request for an action or operation on an AWS resource. Users, roles, federated users via SAML from your corporate directory, applications, or AWS principals. They're all AWS principals. Your AWS account root user is your first principal. Now, as a best practice, do not use your root user for your daily work. Instead, create IAM users and roles. Next come request. When a principal tries to use the AWS Management Console, the AWS API, or the AWS CLI, the principal sends a request to AWS. The request includes information about the action it wants to perform, the resources it wants to access, and other information about the user. Now, as a principal, you must be authenticated or signed into AWS to send a request to AWS. To authenticate from the console as a user, you must sign in with your username and password. Similarly, to authenticate from the API or the CLI, you must provide your access key and the secret key. Next comes authorization. During authorization, AWS uses values from the request context to check for policies that apply to the request. It then uses the policies to determine whether to allow or deny that request. Actions or operations describe the type of access that should be allowed or denied. After your request has been authenticated and authorized, AWS approves those actions or operations in your request. And finally, after AWS approves operations in your request, they can be performed on related resources within your account. So it could be buckets, objects, or set of objects. So let's compare side by side the difference between an IAM user policy and an IAM resource policy, such as the S3 bucket policy. A policy document is written in JSON language, and in this, in the next few slides, we're going to compare them side by side. An IAM user policy is something that hangs off the user or the principal. It defines what can this user do in AWS. Now you can use the IAM user policy if you prefer to keep access control policies in the IAM environment, and it is something that controls all the AWS services. An S3 bucket policy is a resource policy. It hangs off the resource, in this case, the bucket. This defines who can access this S3 resource. So you prefer to keep access control policies in the S3 environment. And it also helps you grant cross-account access to your S3 bucket without using the IAM roles. So here's an example of an IAM user policy. This policy is hanging off a particular IAM principal or a user. And as you can see in this example of the IAM user policy, the principal is implicit. This is because you attach the policy to a particular principal. This particular policy allows this particular user to put and get objects into the reinvent bucket. The next policy, which is on the right-hand side, this is a resource policy, and you can notice that I've highlighted PARC, or principal, action, resource, and condition. You should always keep in mind the PARC mental model. Since the resource policy hangs off of the resource, in this case the S3 bucket, you have to explicitly state the principals that can access your bucket. In this case, this is this particular principal. The action tells you that this particular principal can do a get object call from the reinvent bucket. Now you can also add a condition block where you can add conditions on your policy. And in this particular example, the permissions policy grants a user permission to read objects, but only if the object has a particular object tag and key value, which is project X. Now we talked about IAM policies, we talked about bucket policies. Let's move to access control lists, or ACLs. ACLs are a precursor to the JSON-based policy language. ACLs are something that you can apply to a bucket or an object. And an ACL can only grant a finite set of permissions, such as read, write, or sometimes full control in case of cross-account access, compared to the permissions that you can set in a policy. ACLs are written in the XML format versus JSON for policies. ACLs also has the concept of predefined groups, such as all users, which is anybody in the internet, or any authenticated user, which means anybody with an AWS account. Another pro tip, you should always use caution when you're using these groups because we consider these ACLs groups to be public. 99% of the time, you can achieve anything using bucket policies and user policies to grant access to your resources, which is a bucket or an object. There are some cases where ACLs come in handy, such as we want to provide full control to the bucket owner in case of a cross-account ownership. If you're comfortable with managing both policies and ACLs, then ACLs can give you granular object-level controls, but you have to keep a tab on these type of permissions. Let's talk about the fourth type of access control mechanism, a VPC endpoint. A VPC endpoint enables you to privately connect your VPC or virtual private cloud to supported AWS services without requiring an internet gateway, a NAT device, VPN connection, or DX connection. Instances in your VPC do not require public IP addresses to communicate with the resources in the service. So the traffic between your VPC and the other service does not have to leave the Amazon network. So when you create a gateway endpoint, you can attach an endpoint policy to it, and that controls access to the service to which you're connecting. These endpoint policies are also written in JSON format. Let's take a few examples. A VPC endpoint policy is an IAM resource policy that you attach to an endpoint when you create or modify the endpoint. If you do not attach a policy when you create an endpoint, we attach a default policy for you that allows full access to the service. An endpoint policy does not override or replace IAM user policies or S3 resource policies. It's a separate policy for controlling access from the endpoint to the specified service. All types of policies, the IAM user policy, endpoint policies, bucket policies, and ACLs must grant the necessary permissions for access to Amazon S3 to succeed. So they're all evaluated together and everything must allow permissions. So in this particular example, what I'm doing is I'm creating a policy that restricts access to specific S3 buckets only. You do so by putting or whitelisting this bucket. In this case, this is my secure bucket in the endpoint policy. This is useful if you have other AWS services in your VPC that use S3 buckets. Let's take an example of another endpoint policy. Say in your organization you have many users and applications that need access to your S3 resource through a specific VPC endpoint. Now you can either list all the principals explicitly in your endpoint policy to restrict access, or you can use the principal org ID condition, which I've done here. Now you must be using AWS organizations in this case. Using the condition key AWS:principal org ID in the IAM policy condition, customers can now easily require all principals accessing the AWS resource to be from an account that is associated with their AWS organization. It really simplifies your workflow, because instead of listing all the principals, what I've done is you allow only if your account or the principal belongs to your org. All right. The first two examples were endpoint policies that allow you to restrict access to a service from an endpoint. Now, if you are using an endpoint to Amazon S3, you can also use Amazon S3 bucket policies in combination with the endpoint policies to control access to buckets from specific endpoints or specific VPCs. This example is an example of an S3 bucket policy. So this hangs off the bucket that allows access to a specific bucket from this particular endpoint that has been highlighted here. The policy denies all access to the bucket if the specified endpoint is not being used. Similarly, you can define a VPC, a specific VPC ID that will deny all access if the request is not coming from that particular VPC. So you combine these three together and you can control access to who is accessing your resource and from which VPC endpoint. Last but not the least, pre-signed URLs is another way to give you access to the object identified in the URL, provided that the creator of the pre-signed URL has permissions to access that object. That is, if you receive a pre-signed URL to upload an object, you can upload the object if the creator of that URL has the necessary permissions to upload the object. Now, pre-signed URLs are useful if you want your user or customers to be able to upload specific objects to your bucket, but you don't require them to have AWS security credentials or permissions. So you generate a URL, you provide your security credentials, a bucket name, the object key, the HTTP method, and you also provide an expiration date. Anyone with valid security credentials can create a pre-signed URL. However, in order for you to successfully upload an object, the URL must be created by someone who has permission. Anybody who gets hold of that URL will assume the role that signed the URL and can perform those actions. So this is something that you should keep in mind. This is another pro tip. Okay, so we talked about the different access control mechanisms. Let's move to a new topic. This feature is something that we launched a few days ago. It's called Amazon S3 Block Public Access. Amazon S3 Block Public Access is a new set of security controls that makes it easier for customers to prevent application of any settings that allow public access to data within an S3 bucket or within an account. Now, by default, new S3 bucket settings do not allow public access, and customers can modify these settings to grant public access using policies or object-level permissions. The Amazon S3 Block Public Access settings override those S3 permissions that allow public access, making it easy for the account administrator to set up a centralized control to prevent variation in security configurations. As I mentioned, you can actually apply it at the account level, and if you do that, all the buckets within that account will inherit that property. So once a customer has enabled Amazon S3 Block Public Access settings, they make sure that newly created resources block policies or ACLs that allow public access. For example, an administrator can go to the S3 console and now block public access at the account level to prevent their developers from granting public access to the S3 bucket or object within that account. You can also do it at the bucket level if you so choose to. Once you've made those settings, if you are using AWS organizations, you can write a service control policy or SCP to prevent anybody else from changing those settings. So let's look at those 4 settings that are available. The first setting is to block new public ACLs and uploading new public objects. You should use this setting to ensure that no one can put public ACLs on a bucket or object in the future, and to disallow any objects with public ACLs from being uploaded to your bucket. The second setting is to remove public access granted through public ACLs. You should use this setting to make sure that public access is never allowed to this bucket, overriding any public access settings for individual objects in the bucket now and in the future. The third setting is to block new public bucket policies. You should use this setting to make sure that no one can update a bucket policy to grant public access to the bucket and objects within them. So a public policy is similar to a principal star.star statement. We use automated reasoning powered by Zelkova in the backend to identify if a policy is public or not. The fourth setting, which is block public and cross-account access to buckets that have public policies, this is the most restrictive one. Now, customers told us that they want a way to protect their data and enforce a no public access policy in their environments. If you have written a policy with explicit IAM grants, which allows other accounts to access your S3 buckets and objects, then this setting will not impact those buckets or objects. If the bucket policy has statements that grant anonymous access, such as principal star.star, then we will flag that bucket and restrict access to only authorized users of that account and AWS service principals. This fourth setting protects your buckets while you work to remove those public statements. So if you go to the S3 console now, you will see a new side navigation pane. This side navigation pane, as you can see, is public access settings for this account. It lists out all the 4 settings that we talked about in the previous slide. Now this is at the account level, so it's recommended that if you don't have use cases for public access, you can go and set all of these settings at the account level, and all new buckets and objects that get created in this particular account will be protected from public access. All right, so let's go to the console and see how this experience works. So you looked at the slide where I showed you the public access settings for this account. This is the new side navigation that enables you to enable block public access settings at the account level. And you can do so if you have a single account and you don't want to enable that at the account level. You can go to an individual bucket, go to the permissions tab, and you will see the same set of settings, the 4 settings at the bucket level that you can edit and set it at the bucket level. Now remember, if you have enabled these settings at the account level, this is a redundant step. However, to provide flexibility to our customers, we wanted to have it at both at the account and the bucket level. Now say you have over here, for example, I have 3 buckets and I don't have these settings enabled at the account level, and I want only 2 buckets to have the block public access settings enabled. So I select those 2 buckets and you'll see that this button will come alive, and you can edit them over here and save the settings. If I create a bucket through the console, so let's say we create a PD test bucket. Right, 1, 2, 3. In the workflow, we have added these settings, which will be enabled by default. This is only possible through the console. So if you're creating a bucket through the console, all the settings will be enabled by default. If you create through the API, then the settings are not enabled by default, and you will have to update your workflows if you want all buckets to be created with these settings. Let's go back to our slides. Here you can see the bucket level settings that I was showing you in the console. You can also enable these settings through APIs. The API name is called put public access block. It's a configuration file, so you can see the XML object here, which is public access block configuration, and all the 4 settings that you need to enable with true when you are applying to the account or the bucket. So it's the same API that you point to an endpoint, which is the account or the bucket. The other set of APIs are get public access block and delete public access block. You will need permissions to call these APIs. The 4th API is something that you can see in the console. We are enabling that through the API, which is get bucket policy status. That returns if your bucket policy allows public access or not. All of this is powered by Zelkova. Okay, so we talked about different access control mechanisms. We talked about how to prevent public access. Let's talk about how we authorize requests in Amazon S3. Now, there are 3 checks that I have divided this into. How we evaluate all policies together. But for simplicity's sake, let's talk about the user check, the bucket check, and object check in different context. The user context check is if the requester is an IAM user, the user must have permission from the parent AWS account to which it belongs. So in this step, Amazon S3 evaluates a subset of policies owned by the parent account, also referred to as the context authority. This subset of policies includes the user policy that the parent account attaches to the user. If the parent also owns the resource in the request, in case the bucket, the Amazon S3 also evaluates the corresponding resource policies, the bucket policy, or it could be the bucket ACL, at the same time. The bucket context check is where the requester must have permissions from the bucket owner to perform a specific bucket operation. In this step, Amazon S3 evaluates a subset of policies owned by the AWS account that owns the bucket. Now, the bucket owner can grant permission by using a bucket policy or a bucket ACL. Now, note that if the AWS account that owns the bucket is also the parent account of the IAM user, then it can configure bucket permissions in the user policy. The third one is the object context check. The requester must have permissions from the object owner to perform a specific object operations. Anybody who creates the object is the owner, irrespective of which bucket it goes to. So in this step, Amazon S3 evaluates the object ACL. If the bucket and object owners are the same, access to the object can be granted in the bucket policy, which is evaluated in the bucket context check. So the evaluation logic follows these rules. Pro tip 1, by default, all requests are denied. So you always start the decision at a deny. An explicit allow in the permission policy overrides this default. Now AWS checks each policy. All of these policies are evaluated together. So we collect all the policies and we evaluate them together. If a single policy includes a denied action, AWS will deny the entire request and stop evaluating those policies. This is called an explicit deny. So here we're checking for an explicit deny. If there is an explicit deny, then the final decision is a deny. Now, because requests are denied by default, AWS authorizes your request only if every part of your request is allowed by the applicable policies. So say there is no explicit deny. We'll check is there an allow. If there is, then the final decision is an allow. Now the pro tip is an explicit deny in any policy overrides any allows. That's why we checked that before. If there is no allow, we go back to the default and the final decision is a deny. Let's walk through a few examples to understand how this works. The first example is a bucket operation requested by the bucket owner. Now, over here, PD, who's the user, has root credentials. Because the request is made using root credentials of an AWS account, the user context is not evaluated. In the bucket context check, Amazon S3 reviews the bucket policy to determine if the requester has the permission to perform the operation. If it's authorized, access is granted. If not, access is denied. In the second example, a bucket operation is being requested by an IAM user whose parent AWS account is also the bucket owner. So PD is an IAM user. PD is not the root. It's just an IAM user in that account. So because the request is from an IAM user, in the user context check, S3 evaluates all policies that belong to the parent AWS account to determine if PD has the permission to perform the operation. Now in this example, the account owner to which the user belongs is also the bucket owner. So as a result, in addition to the user policy, S3 also evaluates the bucket policy or the bucket ACL in the same context. And because S3 evaluated the bucket policy as a part of the user context, it does not evaluate the bucket context. If everything is authorized, access is granted. Otherwise, access is denied. In the third example, a bucket operation is requested by an IAM user whose parent AWS account is not the bucket owner. So PD, who's the IAM user here, belongs to account 1, but the bucket belongs to account 2. So in this example, the request is sent by PD. PD will need permissions from both the parent AWS account and the bucket owner. Because the request is from an IAM user, S3 will evaluate the user context check and check all the policies that does PD have the necessary permissions to perform this action. And then in the bucket context check, S3 verifies if bucket owner has written a policy or an ACL that grants PD or allows PD to perform a particular operation. If he has that permission, S3 grants the request and performs the operation. Otherwise, S3 will deny this request. And finally, in this example, let's look at an object operation. In this case, the user belongs to account 1, the bucket is owned by account 2, and the object is owned by account 3. So PD will need the permission from the parent AWS account, the bucket owner, and the object owner. Because the request is in form of an IAM user, S3 evaluates the user context check to verify that the parent AWS account 1 has given PD the permission to perform the requested operation. In the bucket context check, the bucket owner, account 2, is the context authority. So S3 will evaluate if the bucket policy or the bucket ACL has explicitly denied PD access to it or not. Has it allowed? That is, those things are checked. And in the object context, the context authority is AWS account 3, the object owner. So it will evaluate the object ACL to determine if PD has permission to access the object. If he does, and all of these policies are evaluated together, that's why they're in the same box, then S3 authorizes the request. Otherwise, access is denied. Now, this is a good segue for discussing cross-account access, because in this case, this is an example where we discussed cross-account access in Amazon S3. So say you have account A. Account A has created a bucket called account A bucket. Account A has written a bucket policy that grants account B to put an object in account A's bucket. In this particular case, the bucket owner is account A, the object owner is account B. At this point, account A can only delete or deny access to this object because the bucket is owned by account A and account A is paying for the storage of that object. But until and unless account B grants access, read access to account A cannot do a get object. So what B does is it gives full control. Instead of giving read, it gives full control to account A so that account A can do more operations on this object. Say in that organization there are more accounts, account C and account D, and A would like to give account C and account D access to object B1. Now there are two ways you can do so. One, account A can go and update the object ACL that grants explicit access to account C and account D. If you are comfortable with managing IAM policies as well as S3 ACLs, then you are welcome to do so. But it's recommended if you're using IAM for all other AWS services, you go the second option. So with the second option, you create an IAM role called account A role, and you give account A role get object permission. You write a trust policy that allows account C and account D to assume this particular role. This trust policy is in account A, hangs off account A role. You write another trust policy. So account C and account D will write trust policies, which is what you see here, that they can assume account A role. Once they assume account A role, they can also do a get object. Now, I took a simple example to explain how you can manage cross-account access, but this is something that you see in data leak use cases. Say you're collecting logs from different accounts in a centralized bucket, you create an IAM role, and then AWS service principals such as EMR or different other developers can assume that role and get access to those log objects. With cross-account access, another thing that comes into mind is cross-region replication with ownership override. Cross-region replication enables automatic, asynchronous copying of objects across buckets in different AWS regions. Our customers use CRR for disaster recovery, compliance, and business continuity purposes. For business continuity, you can also use the object ownership override to separate the access control of source objects, which is on the left-hand side, and the destination objects, which are the replicas of those objects. If you choose to do so, then in the destination bucket, you would like to have a bucket policy that grants the owner of the source bucket permissions to perform those replication actions. All right, so we talked about managing cross-account access in S3. Let's switch gears and talk about encryption in the cloud. Amazon S3 provides different encryption modes. If your data is in transit, then it is encrypted with HTTPS or TLS. If your data is at rest, you can either do server-side encryption. So SSE S3 is where Amazon S3 manages the master keys as well as data keys, and your data is encrypted within S3. S3 uses strong AES-256 algorithm to encrypt your data. The only thing that you should keep in mind is if an authorized request comes for an object and the object leaves the S3 subsystem, then it is decrypted, and whoever has asked for the object can read the data. To avoid that, you can use SSE KMS, where the master keys are managed by AWS Key Management Service. That allows you to add additional usage grants so that you can better protect your data. Another way to use server-side encryption is where SSEC, where customer provides the master keys and manages it. Or you could do client-side encryption, where the customer or the user encrypts the data on the client side and uploads the data to Amazon S3. But in this case, the clients or the customer will have to manage the master keys and encryption of the data. So AWS uses envelope encryption to protect your data. With envelope encryption, the customer master keys create unique data keys to encrypt these objects. You can choose a specific customer managed master key or accept the AWS managed key for S3 under your account. So if you choose to encrypt your data using AWS KMS, then these are the following actions that happen. Amazon S3 requests a plain text data key and a copy of the key encrypted by using the specified customer managed key or AWS managed key. AWS KMS creates a data key, which is unique, encrypts it by using the master key, and sends both the plain text data key and the encrypted data key to Amazon S3. S3 encrypts the object using the plain text data key and then removes the plain text key from memory as soon as possible. Then S3 stores the encrypted data key as metadata with the encrypted data. Now, if you do a get object, for example, so if you request that your data be decrypted, then S3 will send the encrypted data key to AWS KMS. AWS KMS will decrypt the key by using the appropriate master key and send the plain text key back to S3. S3 decrypts the ciphertext and removes the plain text data key from memory as soon as possible, and the decryption succeeds. So the benefits of using server-side encryption are manifold. It limits the risk of compromised data key. You can centralize access. If you're using AWS KMS, you can also audit it by using AWS CloudTrail. Now, prior to last year, we launched Amazon S3 default encryption. Prior to default encryption, you had to ensure that all puts are encrypted with the respective encryption information, or you could set a bucket policy to reject all unencrypted puts. With default encryption, which is a one-time bucket level setup, you can set up whether you want to encrypt the data with SSE S3 or SSE KMS, and all incoming puts, even if they don't have encryption information, will be encrypted by default. Now, if the incoming put has a different encryption information, such as, say your bucket has SSE S3 enabled, but your incoming put has SSE KMS specified, then we will honor the put that is coming from the customer and encrypt that object using SSE KMS, provided all the right set of permissions and usage grants have been performed. You can also use SSE KMS when doing cross-region replication. In case of cross-region replication, KMS is region-specific, so your data in the source region will be encrypted by the source KMS key. When you send the encrypted object through our network, then it is encrypted by TLS. You provide the KMS key that is specific to the destination region, and S3 and KMS will use that KMS master key to encrypt your object and store it as a replica in the destination region. All right. So let's move to the final section of this webinar. How can you monitor Amazon S3 security on your buckets and objects? First, you can go to the console, and we launched a public indicator last year, so you can see if your bucket has been opened to public. You can use the new feature, Amazon S3 Block Public Access, to ensure that all your buckets and objects within an account are protected and do not allow public access. Another tool or service to see open bucket checks is Trusted Advisor. AWS Trusted Advisor service is provided by AWS Support and has 4 Amazon S3 related checks that checks for open buckets for free. So it will show an alert if your bucket ACL allows read, write, or list access for everyone, or if your bucket policy has open access, or if you have turned on the Amazon S3 Block Public Access settings and your bucket has been flagged to have public access. Remember the 4th setting that we talked about? Or you could use AWS Config. AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources. Config continuously monitors and records your AWS resource configurations and allows you to automate the evaluation of recorded configurations against desired configurations. Our ecosystem partners such as Splunk, ServiceNow, etc., our offerings are fully integrated with the data that comes from AWS Config. You could also use Amazon Macie. Amazon Macie is a security service that uses machine learning to automatically discover, classify, and protect sensitive data in AWS. So if you want to understand like what data do I have in the cloud, where is it located, which of them is PII, has it been exposed, or what type of buckets are open, all of those are available by using Amazon Macie. So we also launched the encryption status in the Amazon S3 inventory report. So if you have compliance use cases where you need to audit which of your objects have been encrypted or not, you can do so by, say, running Athena on the Amazon S3 inventory report. Or you could use an audit service, which is S3 server access logs, that you can turn on for your buckets and objects. Amazon S3 is also integrated with AWS CloudTrail, a service that provides a record of actions taken by a user, role, or an AWS service in Amazon S3. CloudTrail captures a set of API calls for Amazon S3 as events, including calls from the S3 console and from the code calls to the S3 APIs. If you create a trail, you can enable continuous delivery of CloudTrail events to your Amazon S3 bucket, including events for Amazon S3. If you don't configure a trail, you can still view the most recent events in the CloudTrail console in the event history. Using the information collected by CloudTrail, you can determine whether the request was made to Amazon S3, the IP address from which the request was made, who made the request, and when it was made, and many more additional details. All of these tools together can help you better monitor your security settings. So this brings to the end of our webinar. I hope this was a good, informative webinar for you to do a deep dive on how we manage access controls and how you can better secure and protect your data. I can open this webinar up now for questions.